Hello. Today we are going to learn Chapter 7, Radicals. We are going to simplify the radical expression and solve for the radical equation and the distance formula, midpoint formula, and the complex number, operations on complex number. Before we talk about the radical, we need to review the rule of exponent. Here has the exponent rule, product rule, quotient rule, power rule of product, power rule of quotient, zero exponent rule, negative exponent rule. First one we call product rule. Product rule, a to the power m times a to the power n equal a to the power same base is a, add exponent m plus n. For example, 2 to the power 3 times 2 to the power 5 is 2 to the power 3 is 2 times 2 times 2. 2 to the power 5 is 2 times 2 times 2 times 2 times 2. And total, how many 2? 1, 2, 3, 4, 5, 6, 7, 8. That is 3 add 5. And that's 2 to the power 8. So product rule, if the base is a like 2, and the base m like 3, n like 5, so equals a 2 to the power m plus n, 3 plus 5. You add the exponent. If the same base, you add exponents. So that's the first one, product rule. Second one is the quotient rule. Divide a to the power m over a to the power n equal to a to the power, you subtract exponent m over m minus n. For example, 2 to the power 5 over 2 to the power 3, that is, what is 2 to the power 5? 2 times 2 times 2 times 2 times 2. What is 2 to the power 3? 2 times 2 times 2. And 2 divided by 2, 1. 2 divided by 2, 1. 2 divided by 2, 1. So remain 2 square. 2 times 2 is 2 square, so it's 5 minus 3. That is 2 square, and simplify, it's 4. So this we call, quotient rule, a to the power m, a like 2, and a to the power n, n like 3, so it's the same base as a, 5 minus 3, so it's m minus n, subtract exponent. So this is a quotient rule. And power rule, a to the power m to the power n equal exponent times together m times n. So number 3, power example, like 2 to the power 3 square. And so what's this mean? Means this square means 2 to the power 3 times 2 to the power 3. So you can put 2 to the power 3 square. And what is 2 to the, and this is the same base, and use product rule. Same base, 2. You add exponent, 3 add 3. So it's 3 times 2. 3 add 3 is 3 times 2. So you got 3 times 2 to the power 6. So as a power rule, it's just 3 times 2. So a to the power m to the power n equals a to the power m times n. Like a is 2, m is 3, n is 2. So it's 2 to the power 3 times 2. And number 4, example, it's we call the power rule of product, ab to the power n equal a to the power n b to the power n. For example, 2 to the power 2 times 3 to the power 3 is what? It's 2 times 3 and 2 times 3 and 2 times 3. And so you guys 2 times 2 times 2, 2 times 2 times 2, group together, and 3 times 3 times 3, group together. And so you will get it is 2 to the power 1, 2, 3, and 3 to the power 3. So it's 2 to the power 3, 3 to the power 3. So the general form, it's a times b to the power n, a like 2, b like 3, n like 3. So it's a to the 2 to the power 3, a to the power n, and 3 to the power 3, b to the power n. So this we call power rule of product. And the power rule of quotient. This one, power rule of quotient. A over b to the power n equals a to the power n over b to the power n. So for example, this is number 5. 2 to the power 3 to the power 3. What's that mean? Means 2 over 3, 2 over 3, 2 over 3, 3 times. So that's equals 2 times 2 times 2, 3 times 3 times 3. And that equals 2 to the power 3, 3 to the power 3. So this 3 go in each base. So put in general, a over b to the power n equals this n go each base, a to the power n, b to the power n. This we call power rule of quotient. The next one is zero exponent rule. We can prove this. Zero exponent rule, it's how to prove it. Because if we put a to the power n over a to the power n equal what? Like 2 to the power 3 over 2 to the power 3 equal what? Equal a over 8 equal what? Equal 1. Equal 1. And the other side, use same base. Use quotient rule. Left hand side, use quotient, same base, use subtract exponent. Quotient rule, same base is a, you subtract exponent, n minus n. So you do 3 minus 3. Same base is 2, you do 3 minus 3. That is 2 to the power 0. So right side is 1, left side is 2, 2 to the power 0. So we got proof, 2 to the power 0 equal 1. So do the same way. What does this mean? This is a times a, n's of a product. Denominator is also a times a, and n's of a product. And a over a is 1, a over a is 1, cancel, cancel, cancel. And that's equal 1. And on the left hand side, the same base is a, you do subtraction, subtract exponent, n minus n. That is a to the power 0. So the left hand side is a to the power 0 equal 1. That's proved. Zero exponent rule. And number 6. And number 7 is a negative exponent rule. For example, 2 to the power negative 3. If you times 2 to the power 3, is use product rule. 2 to the power product rule. The same base, you add exponent. So same base is 2, you add exponent, negative 3, add 3, equals 2 to the power 0. Negative 3, add 3 is 0. What is 2 to the power 0? Equal 1. So we got this equal 1. So we got 2 to the power negative 3 times 2 to the power 3 equal 1. And then you both sides divided by 2 to the power 3, divided by 2 to the power 3. 2 to the power 3 cancel. So you got 2 to the power negative 3 equal 1 over 2 to the power 3. So put it in general. A to the power negative n times a to the power n equals a to the power, same base is a. Use product rule, you add exponent, negative n add n. That is equals a to the power 0. And then you got this equal, what is a to the power 0? We prove previous one, a to the power 0 equal 1. So we got a to the power negative n times a to the power n equal right side, it's 1. And you divided both sides by a to the power n, both sides. A to the power n cancel. So you got the formula, a to the power negative n equal 1 over a to the power n. So we got the formula. So that's proof the 7 exponent rule. The 7 exponent rule. And we are going to use in this chapter 7. So following radical rule. Radical rule also have a product rule. For example, product rule. Like square root of 2, square root of 3. you do square root of 2 times 3 is square root of 6 times together. So nth root of a, nth root of b is nth root of a times b. This is a product rule. And the quotient rule, second one, quotient rule, example. Square root of 2 over square root of 3. That is equal square root of 2 over 3. So quotient rule is nth root of a over nth root of b equals nth root of a over b. And you can change from exponential form to radical form. Exponential form, the left-hand side is exponential form. A to the power m over n equals a to the power n nth root. Or from right side to left side. So for example, like 2 to the power 3, fourth root. You can change to exponential form, 2 to the power 3 over 4. Or like 3 to the power 3 over 5. You can change to radical form. It's 3 to the power this 3 over 5. So 3 to the power 3, fifth root. So now we are going to use those rules today. The first question on your, those are examples to your homework. The A, square root of 48. 48 you can factor as 16 times 3. 16 you can put 4 square times 3. And then you separate by product rule. Separate it by product rule. Square root of 4 square times 3. Separate square root of 4 square times square root of 3. Product rule. The product rule of radical. Nth root of a times b equals separate, take nth root. So it's a separate square root. Square root. N is 2. Nth root. N is 2. So it's a separate, take square root. And the 4 square root, they are inverse operations. So simplify as a 4. And 3 we cannot square root out. So leave as a radical. So it's a 4 square root of 3. This. Another example like square root of 125. 125 is 25 times 5. You can do prime factorization. What is prime factorization? 125 is divided by 5 is 25. Quotient is 25. 25 you divided by 5, you got 5. So 125 is 5 cubed. And it's 5 squared times 5 to the power 1. 2 add 1 is 3. That's product rule of exponent. So 125 you can separate as 25 times 5. And the 25 is 5 squared. And then use each one take square root. 5 square take square root. Square and the square root cancel each other, get 5. And the 5 with radical, square root of 5. Like 8 take square root. 8 is become 4 times 2. 4 is 2 square. So then 2 square take square root. 2 take square root. Use product rule of radical. You separate. 2 square root cancel each other, get 2, square root of 2. And 18. 18 is 9 times 2. 9 is 3 square. Then 3 square take square root is 3. And 2 with the radical, 3 square root of 2. So that's A. And B, cubic root of square root of negative 27 over x cubed. Now since negative 27, you can put negative 3 cubed. Negative 27. Negative 27 is negative 3 cubed. Because negative 3 is negative 3 times negative 3 times negative 3. Negative 3 times 3, negative 3 is 9. 9 times negative 3, that equals negative 27. So it's a net, and then it's a negative 3 cubed. The negative sign, to the odd power, to the power 3 is still negative. negative sign to the even power, like a square, 4 to the power 4, and become even, become a positive 1. So then x cube, cubic root. Now cubic root are inverse operation. So the number take a cube and then cubic root, they cancel each other, get negative 3. And x cube, cubic root, cancel each other, get x. This x is represent any real numbers. If a negative number, still negative, take cubic root, still negative. A positive number, cubed, positive, take cubic root, is still positive. If x is negative, and this answer is still negative. If x is positive, this still positive. And the negative 125 is negative 5 cubed. Negative 5 times negative 5 is a positive 25 times negative 5 is a negative 125 cubic root. So cancel each other, get negative 5. Denominator, take cubic root. T to the power 6, take cubic root. You can, t to the power 6, use the power rule of exponent. Here, a to the power mn equal a to the power m times n. So here is t to the power 6. You can put 2 times 3. 2 times 3 is 6. And take cubic root, cancel each other, get t squared. Keep negative 5. Separate, take cubic root. Now, there's a quick way to do. For the use the this one, the quick way to do. T to the power 6, take cubic root. You can change to use the from x radical to exponent, m over n, 6 over 3. So this is m over n. You can put, you do a to the power n, nth root equals a to the power m over n. I'll use this rule. So it's a 6 over 3. So it's a t squared. Get this, t squared. That's a quick way to do. You don't need to put this way. And you just do 6 over 3, get 2. Just like this, 3 over 3, got 1. 3 over 3, got 1. That's a quick way to do. And negative 216. Negative 216 is negative 6 cubed. Take cubic root. Cubic and cubic root cancel each other, get negative 6. And y to the power 3 cubic root also cancel each other, get y. If y is negative, and that's cubic root cubed, it's negative. Take cubic root, is still negative. Y is negative. If y is positive, then here y is positive. And C, 144 a squared, take square root. 144 is 12 squared, a squared. And use the product rule. And the 12 squared, take square root. Product rule of radicals. Product rule of radicals is the square root of AB. And you can do square root of A times square root of B. Separate, take square root. So 12 squared, take square root. And A squared, take square root. 12 squared, square root cancel each other is 12. And the square root of a squared, you need to put the absolute value, because like this, a squared, square root. Here a represented any real numbers. For example, if 2 squared, square root, 2 squared is 4, take square root is 2. And the a represented negative number, like negative 2 squared, take square root. Negative 2 squared is 4, take square root is going to be 2. So if a is a positive, then you will get 8. If a is 2, you get 2, no problem. If a is a negative, you will not get negative 2. If a is negative, if it equal a, you will not get negative 2, you will get positive 2. So we need to put absolute value. Like a is negative 2 here. A it's negative 2. put in a, and the square is 4, and then square root become positive 2. It's no longer just a. It's going to be negative a, because a is negative time. So in order to make positive, you have to put absolute value of a. If 2 take absolute value and still 2, positive 2. And the negative 2 takes absolute value is still positive 2. So the a squared, a belong to all the real numbers. A squared take square root is a absolute value. So here, a squared take square root, we have to put a absolute value, become positive. 100t squared, 100 is 10 squared, separate, square root is 10. T squared take square root, you need to put absolute value of t. If without absolute value, we will get negative. If t is negative, then this answer will be negative. So we have to put absolute value, become positive answer. Because t squared become positive. If t is negative number, square become positive. Take square root should be a positive number. So here, put absolute value, it's positive number. 81 is 9 squared. A to the power 4. A to the power 4, use power rule of exponent. Put down 2 to the power 2. Take square root. So square root cancel each other, get 9. Square root cancel each other, get a squared. A squared is always positive. So you don't need to put the bar, because it is already positive number. There's another quick way to do is 4 divided by 2. You will get 2. Is exponent 4 divided radical here is 2. They hide it. It's the radical. We don't put the 2. It means 2. 4 divided by 2 is 2. So this also 49 take square root is 7. And this 6 divided by 2, you got 3. And this one you need to take absolute value, because if a is negative to the power cubed, it's going to be negative. So you have to put absolute value, make positive, because if a is negative to the power 6 become positive, take square root, answer should be positive. But if you don't put absolute value, then a is negative to the cube, it's negative. So you have to make positive, put absolute value. Put this absolute value bar. So this is the basic one is this. A squared take square root equal a absolute value. A is any real numbers. D. X squared minus 6x plus 9 take square root. This one, you can use factor it either way. X squared minus 6x plus 9. You can use trial and error message, x and try. You need to find two number, tying together, like negative 3, tying together is a positive 9. And the negative 3, add the negative 3 is a negative 6. You can check it. First term product, x squared. Outer term product, negative 3x. Inner term product, combined is negative 6x. Last term product is positive 9. So you got it. It's x minus 3 squared. That's by factoring. Or you can do the formula. Formula is a squared minus 2ab. Here's minus, use minus. Completing square formula. That is a minus b quantity square. So it's x squared minus 2 times x times 3. Add 3 square equal to x is a, 3 is a b. So it's x is a, 3 is a b square, quantity square. So it's x minus 3 quantity square. Completing square formula. Or you can do by trial and error method. You got x minus 3 quantity square. Then take square root. And this x minus 3, if x is 0, for example, if you x is 0 plug in, that's going to be minus 3, going to be negative 3. Square become positive 9. And take square root, it should be 3. If you don't put absolute value, then 0 minus 3 is going to be negative 3. So x minus 3 square, take square root, you need to put absolute value because x minus 3 probably can be positive, can be negative. If x greater than 3 is a positive. If x less than 3 is a negative. So depend on x. So in order to be always positive, because any number square become positive, take square root. Answer should be always positive or minimum 0. Minimum is 0. Cannot be negative. So answer cannot be negative in order to become. So x minus 3 can be negative or positive or 0. So you have to put absolute value. Ensure it's not negative number. Answer should be a non-negative number. This also, you can do 25, it's a 5 square. And the 10, you can put 2 times x times 5. And then use formula. Same formula. It's a squared minus 2ab plus b squared equal quantity a minus b quantity squared. This time is a is x, b is 5. So it's x minus 5 quantity squared. Take square root. Any number square, no matter positive or negative or 0, square is going non-negative. Take square root, still non-negative. In order to guarantee non-negative, so put absolute value bar. That's so be careful for this, this kind of questions. Question 2, write in exponential notation. This is a change. This question is a change from radical to exponent, and use radical change to exponent formula, which is this one. From radical form change to exponential form formula. So this example, square root of 7xy, and you will put 7xy to the power 1 square root. Square root means this is 2, and use the formula a to the power n, nth root equals a to the power m over n. So m over n. So you got 7xy. Put the parentheses m over n, 1 over 2. This is a. This is the base. So we put to the power 1, and the square root means here is 2. So m over n, 1 over 2. And the base is put the parentheses. Then next one also, 4a squared b to the power 1. And the cubic root. So 1 over 3. Change to exponential form. Next one, this is the base, 5x cubed. Y to the power 4 is base, to the power 3, 4th root. So this is base, write down the base, 3 over 4. So use this formula, to the power m, nth root, m over n, change to exponential form. Number 3, write back from exponential form to radical form. So it's 2ab cubed, 2ab cubed. And then m over n, 4 put here, n is 5, put here, become radical form. This is xy is the base, and 1 over 2. And 1 to the power 1, you don't have to write out. Square root, you don't need to write out. So it's the square root of xy. And this also, 3 over 2. So it's 2 to the power 3. This one 2 to the power 3. And the 2 over 2 here. And that 2 you don't have to write out. So it's the square root of this. So use the formula. You change from exponential form to radical form to exponential form. And question 4, find the domain of this square root. For this radical function, with radical, so we call radical functions. Now here we consider the number is real numbers. So under this radical cannot be negative, need to be positive, greater than or equal 0. So you let 2x minus 5 and greater than or equal 0, solve for the x. So this under the radical, for example, like x equals 0, you plug in, you will get square root of 2 times 0 minus 5 is negative 5. Square root of negative 5 is not a real number. We will learn at the end of this chapter. It's going to be a complex number. It's a complex number, I. That is a complex number, imaginary number. But here so far we only talk about the real numbers. So we have this, make this under this square root, this one need to be greater than or equal 0. So you let 2x minus 5 positive or 0. Take square root, is still real number. The function value is a real number. If a negative, you take square root, is no longer a real number. It's imaginary number or complex imaginary number. So you let 2x minus 5 greater than or equal 0. Add 5 both sides. 2x greater than or equal 5 divided by 2 both. So it's x greater than or equal 5 over 2. And so domain is all the real numbers greater than or equal 5 over 2. If we write in the interval notation, this is including 5 over 2, use bracket, including 5 over 2. Up to this we call positive infinite, and to put the parenthesis. If there's no equal sign, use parenthesis. If you have equal sign, use bracket, including the end point, 5 over 2. Then next one, question 5. Given a function, f of x equal x squared, the function given f of x equal x squared, and find the function value if a given x as 2 plus square root of 3. So if a given, this is put in x, 2 plus square root of 3, put it in this x, put it in this x. So this get 2 plus square root of 3 quantity square. And square, so you can use the product rule. The product rule is a plus b quantity square equal a square plus 2ab plus b square. So this question is a is 2, b is the square root of 3, square. That is a is 2. A is 2, b is the square root of 3, b is the square root of 3. You square it. So you got 2 square is 4, plus 2 times 2 is 4, square root of 3, plus this, a number takes square root and the take square is still itself. And 4 add 3, it gets 7 plus 4, square root of 3. So we got this one. Use the formula. If you cannot use, if you don't memorize the formula, you can use FOIL. And FOIL is 2 add the square root of 3 times 2 add the square root of 3. FOIL. First term product, 2 times 2 is 4. Outer term product, 2 square root of 3. Add inner term product, 2 square root of 3. Add last term product, square root of times 3. Square root of 3 times square root of 3 is square root of 3 squared. So then it's 4 plus the 2 term combined and get 4 square root of 3. Add and square cancel each other, it's 3. And then combined 7 plus 4 square root of 3. So either way, you can use formula or use the FOIL to do. Or better use formula because that formula we will use in the future. So you have to familiar with formula. So this, for example, like if x is 5 minus square root of 4. So 5 minus square root of 4, put it into the x. Also put equal. This put replace by x. So get 5 equal 5 minus square root of 4 square. This x use 5 minus square root of 4, plug in. Get 5 minus square root of 4 quantity square. And use completing square formula. Completing square formula is a minus b quantity square equal a square minus 2ab plus b square. If a plus, use plus. If minus, here use minus. So you got a squared, a is 5, 5 squared, minus 2 times a is 5, b is square root of 4. Oh, this is not a good example. Okay, I'll change it. Should be square root of 5. Yeah, 5. Because 4 you can square root out, get 2. So it's better change it. Let's see, 5, square root of 5. Square root of 5. and 2 times square root of 5. Square root of 5 squared. So you got 5 squared is 25, and 2 times 5 is 10. And here, square root of 5. Because the square root of 4, you got 2. You can further simplify. This square root cancel each other, get 5. So then you got this is 30. 25 add 5. It's 30 minus 10 square root of 5. So this one. And another example, square root of 6 plus 3 square root of 2. So this is x, f of x. X is this. This x put in here in x equal. This is x squared, which is this square. So it's the square root of 6 plus 3 square root of 2, quantity square. X is this one, and plug in here x. So it's this x squared. So put this square. And then first term, use formula. First term square, square root of 6 square, plus 2 times first term times second term, add second term square. So the square root cancel each other, get 6, plus 2 times 3 is 6. And use product rule, square root of 6 times square root of 2. Product rule of radical here. Square root of A times square root of B. It's not there. It's previous page. So it's the square root of A times square root of B equals square root of A times B. Formula. So you time together. Square root of 6 times square root of 2 is the square root of 6 times 2 is 12. Add this. Use the power rule of exponent. So AB to the power 2 equal A squared, B squared. So here A is 3. B is the square of 2 square. So it's 3 square times square of 2 square. So you got 3 square, square of 2 square. Use the power rule of product. So this this one is 6 plus 6. 12 is 4 times 3. Take square root. Plus 3 square is 9. Square root, square cancel each other. Times by 2. Then 6 plus 6 times. Separate, take square root. 4 take square root out is 2. 3 still under radical. Plus 9 times 2 is 18. So then 6 plus 18 is 24. 6 times 2 is 12. Square root of 3. And you cannot add together, get 36. You cannot do this. 36. You cannot add together. Because multiplication do first, then do addition. The order operations. So this time together, then add 24. So we cannot do add together, get 36, and then times square root of 3. The order operation is multiplication do first, then do addition. So we cannot add first, then do multiplication. So you cannot go further simplify. Get 36 square root of 3. It's wrong. It's the wrong way. Number 6. Simplify. Write all answer using radical notation. With radicals, assume that all the variables represent a positive number. All are positive number. Like here, x, y positive, a, b, all are positive numbers. So this take cubic root. So first of all, 8 we can put 2 to the power 3. X to the power 4 we can separate as x to the power 3 times x to the power 1, because 3 add 1 is 4. Y to the 12, we can put 4 times 3. Y to the power 4 to the power 3. Power rule. 4 times 3 is 12. Now then, separate, take product rule. This one take cubic root. 2 cube, cubic root, get 2. S cube, cubic root, cancel each other, get x. And x take cubic root and still x cubic root. And y to the power 4 cubed. Cubic root cancel each other, get y to the power 4. And normally we put a radical to the right, to the end. So put 2x y to the power 4, and then cubic root of x. So is it those 1, 2, 3, 4, 4 factors timed together. like this cubic. So 64 we can factor as a 4 cubed. A to the power 7. 7 divided by 3 got 2. Remainder is 1. So it's 2 times 3 is 6. Add 1 equals 7. So we can put a squared to cubed. A to the power 1. A to the power 1 is still a. And then a divided by 3. And a divided by 3. A divided by 3. Quotient is 2. Remainder is 2. So a equals 3 times 2, add 2. Now this question is b to the power a. So b to the power a is b to the power this. So you got b to the power 3. Here is cubic root. So you can put 3 times b squared, because 2 times 3 is 6. Add 2 equal 8. So then you separate, become this b squared cubic root, b squared take cubic root. Let's see. This one. I can tell you another quick way. So now so far is this. I'll tell you quick way later. So cubic root cancel, get 4. And this cubic root cancel, get a squared. And this a still under cubic root. And the cubic root cancel, get b squared. And this is b squared still under radicals. Then the radical tying together, get cubic root. This needs to go further. So this 4a squared and the b squared and the 2 tying together, cubic root of a times cubic root of b squared need tying together, get cubic root of ab squared. So that will be the answer. This is the final answer. This one is not final answer yet. So it should be this one. You need to go further. Let's tell you another quick way to do. 64a7b b to the power a. The quick way. b to the power a. Take cubic root. The quick way. First of all, 64. You can put 4 cubed, cubic root. And a to the power 7, take cubic root. B to the power 8, cubic root. Right. Each one take cubic root. And you don't need to write this step. And you just need 64 is a 4 cube. A to the power 7b cube, cubic root. So you do 4, 3 over 3. It's 1. A, 7 over 3. 7 divided by 3. Quotient is 2. 3 times 2 is 6. Remainder is 1. Cubic root. So put this 2 outside the radical. Get a squared. And this 1 inside the radical. A to the power 1. And this 8 also divided. A divided by 3. Got quotient is 2. 3 times 2 is 6. Remainder is 2. And this base is b. Put b. This 2 put outside the radical. This 2 put inside the radical. That's a quick way to do. So the final answer, it's 4 to the power 1. It's 4a squared b squared cubic root of ab squared. This is this one. The answer. That's the quick way to do.